This video is all about finding your radians on the unit circle, labeling your triangles with the correct ratios so then you can apply your trigonomic functions. Before you can start using trigonometry functions, you have to understand the ratios that go along with the degrees of a triangle and which of those then also goes along with the radians like pi over 4, pi over 3, and pi over 6. So that's what we're going to start with today. So the first thing we're going to do is look at this very basic triangle, okay? All I want you to do is find the length of the hypotenuse, which should be super easy for you, right? We're going to use a squared plus b squared equals c squared. A is 1, b is 1, and then we're solving for c. So 1 squared 1, 1 is 2, so 2 equals c squared. So the square root of 2 equals c. That's what you need to know for the hypotenuse. It's a 1 square root of 2 ratio. Now, how does that apply to our triangle? Well, we know if two sides are the same, that makes this an isosceles triangle. We know that we have a right angle in the corner. So what are the measurements of the other two angles? Well, a triangle is a total of 180 degrees. You have 90 degrees here in the corner. So 180 minus 90, we are left with 90 degrees. And we have to split 90 degrees in half to get those two other angles. So 90 divided by 2 is 45. So here are our triangle ratios. It's a 45, 45, 90 triangle. 45, 45, 90. You want to write this down. This is super important. And then we knew it's 1, 1, and then we found out this side was square root of 2. So then you put your ratios that go with the angle across from it. So the 90 goes with the square root of 2. Then the 45 goes to the side with a 1. And then, of course, 45 goes to the side of 1, which should make sense. Since 45 and 45 are the same, their ratio sides are also going to be the same. This is super important. You will use these ratios over and over and over again. Put it on a colored sheet of paper, highlight it, put it in fun colors, whatever you need to do. This is your first set of degree ratios to the side lengths that you need to have memorized. There's one other set of degrees and ratios that you have to have memorized. We're going to try it on this one. So here is a triangle. It's an equilateral triangle. You'll see that I cut it in half. And we want to find the length first of DB. Well, if this is an equilateral triangle, that means this whole thing is 2. So DB is going to be 1 because I'm bisecting it right through the center. So now I took off the other half of the triangle because now what I want to find is the length of CD. So again, what are we going to use here? That's right. A squared plus b squared equals c squared. I'm going to say my A is 1 squared plus b squared. That's the side B over here, right? Because these are the legs of the triangle. C squared is 2 squared because C is my hypotenuse. So now I have 1 plus b squared equals 4. Move my 1 to the other side. B squared equals 3. So b equals the square root of 3. This is the other set of ratios that you need to know. Now that we have all the sides labeled with their lengths, now we have to find out what the degrees are. So we know that this is 90 degrees. And remember, this came from an equilateral triangle. So if you had this side over here, and this was your equilateral triangle, right? You take 180 divided by 3, which means each of these corner angles were 60 degrees. So that makes B 60 degrees. And again, they have to add up to 180. So then you'll get 30 at the top, or you could just think this was 60 and you divided it in half, so that's 30. So now how do our degrees and our ratios line up together? So we have 30, 60, 90, these are the degrees, and which sides correspond? So it's always across from the angle. So 1 goes to the 30 degrees, the 60 is your square root of 3, and your 90 is 2. Again, this is another set of ratios and degrees that you must have memorized. You will use these over and over and over again. So make sure you highlight it, color it, put it on a sticky note, a fancy sheet of paper, whatever it is, for you to remember these ratios with these degrees. Okay, now that we know the degrees and the ratios and how they relate together, let's see how to use them on a unit circle with trigonometry and radians. So this first example wants us to try to find pi over 4, and then we're going to label the triangle. If you're not sure how to find pi over 4 on your family, make sure you check out my other video that talks all about labeling the unit circle and all of the degrees, families that you'll need to know how to label. So pi over 4 we know is in quadrant 1. This is pi over 4, right? That's the pi over 4 spot. What you're going to do is draw a line down to create a right triangle. And pi over 4, again, hopefully you remember, is your 45 degrees relationship. Now, we're going to use that 45, 45, 90, and that ratio is 1, 1, square root of 2. So across from the 45 degrees goes 1. Across from the 90 goes square root of 2. And across this other guy up here would be 45 as well. Then his side is going to be 1. So that's how you label a pi over 4, 45 degrees with the correct ratios. Now the first quadrant is usually always easier. Let's try something in a second quadrant. So this is 5 pi over 6. So again, you have to remember, where does 5 pi over 6 fall on your unit circle and on the xy plane? So hopefully you remember that over in this position here is pi. Well, if we're doing 6 as our denominator, this would technically be 6 pi over 6, which means 5 pi over 6 would be right up here. So the difference between 5 pi over 6 and 6 pi over 6 is just what? Yeah, pi over 6. And your pi over 6 family is which degrees in the corner? That's right, this is your 30 degrees mark. So we're going to do a straight line down to create that right angle. This is our 30 degrees, makes this 90, which tells me we're doing a 30, 60, 90 ratio. So we know those ratios are 1, square root of 3, 2. Across from the 30 degrees gets the 1, across from the 90 degrees gets the 2, and so this makes this guy 60 degrees in the corner, which means the ratio across from him is square root of 3. But now, we are to the left side of the x-axis, so this is actually negative square root of 3. Okay, so the first thing you have to remember is the pi over 6 family will have 30 degrees in the corner. Then you go ahead and label the sides with the degrees with the corresponding ratios, and then you just pay attention, because this is to the left side of the x-axis, this has to be a negative square root of 3. So that's the only thing you have to remember when you're working in a different quadrant, if your x and y values will be positive or negative. Let's try another. All right, now we have 4 pi over 3. So where is this going to be on our unit circle? The first thing I like to think about is, okay, if this is my pi position and my denominator is 3, this is technically 3 pi over 3. So 4 pi over 3 has to keep going further down. So this would be my 4 pi over 3 position. The difference between 3 pi over 3 and 4 pi over 3 is, that's right, just pi over 3. So the pi over 3, remember, is our 60 degree angle. So 60 degrees goes in the corner. I'm going to make my triangle. Here's my right angle. So again, we're using the 30, 60, 90 ratios, which is 1 square root of 3 and 2. Okay, across from the 60 degrees goes our square root of 3. But again, we're below our origin, below, so our y values are negative, so it's negative square root of 3. Your hypotenuse is always going to be positive, because if you think of a squared plus b squared equals c squared, when you take the square root, it's going to be positive, right? And then our x value, so the 30 degrees is down here in the corner, is 1, but again, because we're to the left of the origin, it's going to be a negative 1. So this is how you would label that triangle for 4 pi over 3. Okay, let's try this one. 7 pi over 4. So step 1, finding out where this is on your unit circle in the xy plane. So we're going to come over here. We know that this spot over here is 2 pi, which means if our denominator is 4, this is actually 8 pi over 4, correct? And we want 7 pi over 4, which means it's just 1 pi over 4 lower. So here is going to be our 7 pi over 4. So again, the difference between these two is just pi over 4, which means that's a 45-degree angle. So this is a 45-degree angle. We'll make our triangle here, right triangle, which means we have a 45, 45, 90 triangle, and those ratios, 1, 1, square root of 2. So now let's go ahead and label. Across from the 45 is 1, but again, we're below the x-axis, so our y values are negative. The other 45 is down here, which means its ratio is up over here. Positive 1, because the x's are in the positive. And our square root of 2 is our hypotenuse. So that is how you go through and label triangles, given the radians, finding the matching degrees, and then labeling with the appropriate ratios on the triangle. Now, in my next video, I'm going to show you how to apply the trigonometry to this piece as well. Be sure to subscribe and share this video with another friend who's going through trigonometry.